Justin. Where are we at? We have this question here that you never finished right here, and that's actually a pretty common one that students have. So I'm going to show you basically how to do that real quick. Real easy. What you're going to do is you're going to take this idea where you have this hill, and it doesn't really matter which one, they're all the same way. The force and the distance up the hill will give you the MGH, where this is the distance here and this is the H here up the hill. And so this is basically saying that work is going to be, and yeah, that equals gravitational potential energy, or is stored as gravitational potential energy. So FD equals MGH, where this is the average force. Basically saying that you're going to use a very smooth pushing motion up the hill, and that force is what we're looking for. Now the MGH is the same in each case. It's 0.5 times 9.8 times 0.3, and that equals 1.47 joules. And the distance changes though. So if you have a ramp that's very steep, the force, the height is the same, but this distance is much shorter, and so the force is much greater. Whereas if you had a ramp that was much longer, the height would still be the same, but the distance would be much greater. And so the greater distance, or the less the distance, the force will change accordingly. So we're going to change this each time. D will change, and then we're gonna compute for the force. So this distance, I'm not sure what the distance was in the first case. It was 0.6, 0.5, 0.4, 0.34, and 0.3. 0.3 is basically just going to be equal to the weight, because you're going straight up, right? So anyways, where are we here? So the distance, we could put in 0.6 here, and then we solve for F, right? So the equation literally turns from this equation here, if we just rearrange it, we could say that the force is equal to the gravitational potential energy over the ramp distance. And that will give you the force for all the cases. And you just change this depending on what the ramp distance is. Okay, so give that a try. That's definitely a test question. And remember, we're looking for that force, and the distance is changing. All right, so give that a try, and we will see how you do, okay?